Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the T flip-flops, truth table, characteristic table and excitation table. So my dear students, in the previous lecture, we had discussed what is a T flip-flop, and in the last set of lectures, we had discussed what is a flip-flop, what are the different types of flip-flop like SR flip-flop, JK flip-flop and D flip-flop. And also we had mentioned the master-slave flip-flop concept. So my dear students, let us introduce the truth table, characteristic table and excitation table of T flip-flop in this lecture. So if we are analyzing the truth table of a T flip-flop, the T flip-flop with the clock is equal to 0 and the T value either 0 or 1 results in a memory condition, that is the output will be Qn, that is a previous state itself. In the case of clock 1 and T0, this will also result in a memory condition, that is we are dealing with a Qn output, that is the previous output itself. In the case of clock 1 and T1, then the output will be Qn complement, that is the previous output is complemented or inverted in this case. So this is the truth table of T flip-flop. Based upon this truth table, we are generating the characteristic table. Before that, let us say what the T stands for the T flip-flop. In the case of a T flip-flop, the T is representing the condition toggle, that is the output is changing with the input value, that is if the input is 0, then the output will be 1, and if the input is 1, then the output will be 0. So this can be analyzed in the case of a characteristic table. So firstly, we are starting with the characteristic table. The input of characteristic table are Qn as well as T, and the output is Qn plus 1. So firstly, we are starting with the conditions 0, 0, 0, 1, 1, 0 and 1, 1. If the input values are Qn and T as 0, 0, that is let us check the truth table with the T value 0. The truth table with the T value 0 results in an output of Qn, that is here in the characteristic table the Qn value is 0. Thus we can say that the output Qn plus 1 in the characteristic table will be 0 itself. And if we are giving an input T as 1, then analyze the truth table here. If the input is 1, then the output is Qn complement, that is if we are getting an input of T is equal to 1 in the characteristic table and Qn as 0, then the output will be Qn complement. Here 0 complement results in an output of 1. So we are moving to the third case. Here the T value is 0. So in the truth table, if the T is 0, then the output will be Qn. So here the Qn is 1 in the characteristic table, thus the output Qn plus 1, which is equal to 1 itself. And finally, fourth case, that is T value equal to 1. In the truth table, the T value 1 results in an output of Qn complement. In the characteristic table, the Qn value is 1, thus Qn complement is equal to 1 complement, which is equal to 0. So this is the characteristic table of the T flip-flop. So if we are moving towards the excitation table, this excitation table is designed with the help of a characteristic table, and this excitation table is used to convert the different flip-flops as well as for the condition of counters. So excitation table is very much important, and this excitation table is formed with the help of a characteristic table. So the input values of excitation table are Qn as well as Qn plus 1, and the output is the T. So the different combinations are 0, 0, 0, 1, 1, 0 and 1, 1. And if we are moving towards the first case, that is Qn value is 0 and Qn plus 1 value is 0, that is a 0, 0 condition. In the characteristic table, the Qn value 0 and Qn plus 1 value 0 is marked over here, and here the output value, that is the T value, is 0. Thus in the excitation table, the first case results in an output T is equal to 0. The second case is Qn is 0 and Qn plus 1 is 1. This is marked in the characteristic table. Here the T value is 1, thus the output T is equal to 1 in the excitation table. And if we are moving towards the third case, that is the excitation table with Qn as 1 and Qn plus 1 as 0. So this is marked in the characteristic table, and here the value is t is equal to 1. Thus the output of this excitation table will be 1. And finally, if we are moving towards the 1 1 condition, the 1 1 condition qn is equal to 1, qn plus 1 is equal to 1 is represented in this characteristic table. Here the output value is t is equal to 0. Thus the output of the excitation table is 0. So my dear students, this is the excitation table of the T flip-flop. So dear students, as we mentioned, this excitation table is generated with the help of a characteristic table, and this excitation table is used in the case of counters as well as for the flip-flop conversions. So my dear students, hope you had understood this topic. So dear students, kindly go through this assignment question. Our question is, write notes on characteristic and excitation table of flip-flop. So dear students, in the upcoming set of lectures, we will discuss the different digital electronic equipments as well as the different digital electronic basic components. So dear students, see you soon. Until then, goodbye, thank you, and all the best.